In this video, I'm going to show you how to run, schedule, and interpret the AppNeta Performance Overview Report. The Performance Overview Report is useful for finding stability issues or changes in performance across all raw metrics for multiple network paths. This report is meant to be used by day-to-day AppNeta administrators and other teams that need access to the raw data for situational reviews of path performance. We recommend that you use the Application Quality Report instead if you're looking to report to leadership on overall uptime and performance trends. The Performance Overview Report can also be used to identify trends in user performance over time across hours, days, or weeks of information. A common use case is to run the Performance Overview Report for paths from many workstation monitoring points to a common reliable target, such as one of AppNeta's global monitoring targets, or to an AppNeta device at a central data center. That way we're validating performance to something we know responds well, and we can use reliably to note performance trends week over week. Let's take a look at how to create, then interpret the report for a similar performance use case. To start, navigate to the Reports List page and select the Performance Overview Report. Next, we need to edit our path filters so that the report is only looking at the paths you're interested in. There are three options for filtering paths. If you already have a saved list, you can select it here. If not, you can also select various criteria. The filter criteria are based on tags applied to your network paths. As you select your filter criteria, the list of paths is displayed. Control or Command click to deselect a filter or to add additional options. Once you have the filters finalized, save the list of paths for future use. The third option is to filter to a set of specific paths picked from the list. These can be saved as a static list, which is typically useful for a quick look at a few specific paths for a specific and often one-time purpose. For my purpose, I've already set up a saved list for paths targeting the global monitoring target. Once you've updated your filter criteria, you have an option to save the filter configuration for this report, which is useful if you expect that you would want to run the report again later. Organization admins can share filters with other users in the organization to allow other users to replicate this report quickly and easily. The next step is to select the time frame. Options are to see the average values measured over the past 15 minutes, past hour, past day, or past week. Finally, we need to identify if we want to highlight values that differ from the previous period, in our case compared to the previous 24 hours. You can select whether you want to highlight huge swings in performance or identify smaller variations from the previous period. Now that we have run the report, let's review how to interpret the results. We'll start from the left side. This icon represents the current path status, which indicates the state of the path at the time the report is run. Paths are in an OK state if all performance metrics currently meet or exceed the required levels of the alert profile. Violated paths don't currently meet those required performance levels, and paths that were not monitored during the specific time period will not be included in the report. This includes paths that were disabled or lost connectivity for the entire period. For dual-ended paths such as these, each direction is a separate row, with the arrows indicating which row is the outbound or inbound direction. Single-ended paths have just one row on the table. The arrow icon in the second column indicates which rows relate to dual-ended or single-ended paths. Next, we have the network path name, which also happens to be the default sort option. Each column header can be clicked to change how the report is sorted. Then we have the average performance metrics for each path during the report period. The columns are filled out depending on if the path is configured to emulate data traffic with larger payloads or voice traffic with smaller payloads, or both data and voice. For paths set to data only, the voice metrics, loss, jitter, and MOS, will be blank. And similarly, for paths set to measure voice only, the data metric columns for capacity, data loss, and jitter will be blank. Capacity is an end-to-end measurement representing how application data experiences the network between a monitoring point and its target. Total capacity is the peak transmission rate observed, taking into account variations in latency and cross-traffic. That's then split into available capacity, which is the part of total capacity that's available for use, and utilized capacity, which is the remainder. Round trip time is the average time it takes a packet to go from the source monitoring point to the path target and back. The number displayed here is the average round trip time for the report's time period. Latency is the time it takes a packet to get from the source to the target. It's calculated as half the round trip time of the fastest packet, which means for this path, with around 6 milliseconds of latency, I know that the fastest round trip time was about 12 milliseconds. But since the average round trip time is so much higher, I'll want to look into the routing on that path to understand what's causing the average to be so much higher. I'll get back to this in a minute. Data and voice loss is a simple measure of the number of packets of either type that was sent, but didn't make it to their destination. Jitter measures variation in latency. And the mean opinion score, or MOS, is a function of loss, latency, and jitter, and is only calculated for paths enabled for voice monitoring. More information about these metrics can be found in our documentation. Each of these column headers can be clicked to change the sort options on the report. This is a great option if looking for the worst or best performing paths based on a specific metric. For example, if you're looking to identify the lowest total capacity paths or the highest packet loss. Now remember how we specified to highlight any values that are significantly different from the previous period? Green highlights indicate an improvement over the previous report period, while red highlights represent worse performance. Hover over the value to display the title text with the average for the previous report period. In this case, I can see that my average round trip time yesterday was around 16 milliseconds, which is much closer to what I'd expect with a one-way latency of 6 milliseconds. I'm even more interested now to see what happened on this path between yesterday and today. From this report, you can click on the path name to look at the detailed timeline for the network path. Let's take a quick detour from the report to investigate. I can immediately see that there were many network changes happening yesterday that cleared up today. Network change events indicate changes in the sequence of the networks along the path. Zooming out to 7 days tells me these changes are not normal for this particular path. I can see a drop in total capacity, increased jitter, and there's the day-long spike in average round-trip time. What I'm really interested in here is those network changes, so I'll zoom in on when they started. Looks like it was right around 12:30 a.m. when connectivity dropped briefly, and an ISP change was detected. Next, I'll head to the Route Visual tool. Let's enable the Networks view and go to the time when the changes were happening. Let's take a look at 15 minutes on either side. I can immediately see when I scrub along the timeline that traffic is switching from CenturyLink to Verso. Then it starts flapping back and forth between Hurricane and Cogent. Looking at the day before, I can see the path was stable, routing through CenturyLink and Level 3. At this point in a real investigation, I would need to determine if there were any known changes made during this period. Depending on my role, that might involve reaching out to the internal team responsible for the network or directly to the carrier and providing them with my findings. For that, I can export the route data from here. But let's get back to the report. There are two ways to generate a PDF version of the report. You can either download a PDF copy, or you can schedule it to be sent to you and others on a given schedule. This schedule will be visible to others, so it's important to be clear about the purpose of the report when giving it a name. The type of report and saved list are both taken from your current view. You can then set the frequency. The report will be sent just after the end of the configured period. So if you configure the report to be sent weekly, it will be sent just after midnight on Sunday and will include the previous 7 days' averages. Customize the PDF file name using variables. And then finally specify who should receive the report. Before you automate sending the report to anyone else, you may want to review the first one yourself. Once you've reviewed the report and made any configuration changes, you can come back to add additional contacts. Find the scheduled report in the list and edit it to CC other email addresses. One thing to note is that a scheduled report will be sorted by path name, whereas a downloaded report like this one will be sorted by whichever column was sorted on screen when you downloaded it. So that's it. In a few quick steps, we have a simple report summarizing network path data for a selection of paths. Remember, for a performance report suitable for leadership, check out our video on the application quality report. And as always, thanks for watching.